Hello dear students, good evening. Welcome to live science revision classes. We have left with around 10 days for the exam. It is very important to revise all the chapters, especially science. To score good marks in science, it is very important to read textbook, that too conceptually. Today we'll be revising 4 units: electricity, chemical reactions and equations, life process, and acid, bases and salts. All these chapters are very important from the examination point of view. Keep your textbook, part 1 textbook with you. Make a note of all the keywords. If not possible, at least underline those keywords what we are going to discuss, and try to revise all those. To score good marks in science, you should read textbook. So you should have lot of patience. For next 1.5 hours or 2 hours, we'll be revising the 4 chapters. We'll be going in detail. Do attend the complete live session. If you have not subscribed the channel, do subscribe. And also for science 100 plus questions and 20 worksheets, I've already uploaded in my Telegram group. Do join the Telegram group. Now we'll start with the unit, these 4 units. Make a note what are the questions I tell repeatedly. In case of any mistakes, do pardon me. We'll start with the revision class. So unit electricity, from the examination point of view, you can score around 7 marks, 6 to 7 marks. Now make a note of all the keywords or the points what we are going to discuss now. In the first page of the unit electricity, you can get 1 mark definition of what is a switch. A switch makes a conducting link between the cell and the bulb. What is switch? It is a conducting link between the cell and the electric bulb. 1 mark, you can make a note. You can just make a note of the word the switch. Next important definition, electric circuit. A continuous and closed path of an electric current is called as what? Electric circuit. Next, the important definition what you can expect is definition of electric current. Just make a note of the key word, not the whole point. Just make a note, a switch. Next, second keyword, electric circuit. Next, electric current. Everything is there in the textbook. Just you need to make a note of the keyword in your notebook. Next, the important definition is electric current. What is electric current? Electric current is expressed by the flow of charges to a particular area in unit time. Otherwise, you can say the simple definition for electric current is it is the rate of flow of charges. It is the rate of flow of charges. What is electric current? Electric current is defined as the rate of flow of charges. Otherwise, you can say as amount of charges flowing to a particular area in unit time. Now, what is the conventional direction of electric current? It is the direction of for electric current taken opposite to flow of electrons. So these are the important questions you can get in page 1 of unit electricity. What we have discussed is a switch, an electric circuit, and the definition of electric current, and the conventional, the flow of electric current. It is the opposite to the direction of flow of electrons, which are negative charges. So these are the important points you can concentrate on the unit electricity in page 1. Next page, we have the important definition, the current. The current is defined as the what? It is defined as the flow of charges per unit time. So the important formula is here is I equals Q by T. Make a note of this formula. The current I equals what? Q by And the SI unit of electric charge, it can be asked in MCQ or 1 mark. What is the SI unit of electric charge? The SI unit of electric charge is coulomb. Next, the SI unit of electric current is ampere. So from this unit, definite 1 marks question based on unit you can expect. Here the electric current is expressed by the unit what? Ampere. And also they can ask define 1 ampere. Define 1 ampere. 1 ampere is defined as the flow of 1 coulomb of charge per second. Is defined as what? The 1 ampere. So then, to measure the flow of current, electric current in a circuit, we use an instrument called as what? Ammeter. Definition of ammeter. How ammeter is connected? Ammeter is always connected in series. Ammeter is always connected in series. And definite and important question for your examination is the simple electric circuit. The simple electric circuit. 2 mark question. Very important diagram. Simple electric circuit. Next, so here in this paragraph, the important question what you can expect is the current, the formula to find out the current, that is I equals Q by T. Then SI unit of electric charge is coulomb. Then the electric current is expressed by unit what? Ampere. The SI unit of electric current is ampere. Then definition of 1 ampere, that is 1 coulomb divided by 1 second. And the instrument used to measure the electric current in a circuit is ammeter, and always it is connected in series in the circuit. Always the ammeter is connected in the series in an electric circuit. And important diagram, simple electric circuit. Next, in next page what we have is the concept is electric potential and potential difference. Here you can expect the definition of potential difference. You can expect, make a note, you can make a note the definition of electric potential difference between 2 points. Electric potential difference between 2 points in an electric circuit. The potential difference between 2 points, always the potential difference is measured between 2 points. The electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to another point. Potential difference between any 2 points in an electric circuit is defined as the work done to move a unit charge from one point to another point. Potential difference is expressed by V equals what? W by Q. Work done by charge. Work done by charge. Potential difference V equals work done by charge. The SI unit of potential difference is volt. And you can have 1 mark definition. Define 1 volt. 1 volt is defined as 1 joule of work done to move a charge of 1 coulomb from one point to another point is defined as 1 volt. How potential difference is measured? The potential difference is measured by a instrument called as voltmeter. Just make a note of the keyword voltmeter in your book. And voltmeter is always connected in parallel. Ammeter is connected in series, whereas the voltmeter is connected in parallel. Based on the concept electric potential and potential difference, what you can expect? You can expect the definition of electric potential difference. What is electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to another point. Potential difference V equals what? W by Q. V equals what? W by Q. What is the SI unit of potential difference? It is volt. And also you can expect 1 mark definition. Define 1 volt. You have a simple problem here. How much work is done in moving a 2 coulomb across 2 points having potential difference 12 volts? Work done, potential difference V equals W by Q. W equals V into Q. How much is V? V equals 2. Q is what? 2. 12 into 2 is 24 joules. How much work is done? 24 joules of work is done to move 2 coulomb charges. Next, circuit symbols. You can expect definite circuit symbols for 1 mark. You can go through all the circuit symbols. Circuit symbol whether it is resistance, ammeter or rheostat, wire joint, crossing without joining, switch, open, close, SL, a battery. All these are important. Students, if you go through the textbook, it will be very easy to study and score good marks in science. Next, the important concept is Ohm's law. Based on Ohm's law, definitely you can expect problem or you can expect 2 mark question. So in one of the examination, they have given a graph, voltage versus current in a table where you need to find out the resistance. So what you can do is, when the voltage against the current is given in a graph, you can easily calculate by finding the potential difference and the current. It will be given in the table, just you need to find out. For all the values, the resistance will be same because resistance is a constant. Now the important definition of Ohm's law. So in laws and all you cannot change, however it's there in the textbook, you need to write as it is. So the Ohm's law states that the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is called as Ohm's law. The simple definition is V is directly proportional to I. The potential difference in an electric circuit is directly proportional to the current flowing through it. Okay, so V is proportional to I. This is called as what? Ohm's law. If you remove the proportionality, we get a constant called as what? Resistance. R is a constant. So V equals what? I into R. V equals I into R. This is what? Ohm's law. Based on Ohm's law, definite question. V equals IR. What is R here? R is a constant called as resistance. What is resistance? It is the property of a conductor to resist the flow of charges. What is the definition of resistance? It is the property of an conductor to resist the flow of charges. And important question what you can expect is, define 1 ohm. V equals what? IR. V equals IR. R equals V by I. So 1 ohm equals 1 volt by 1 ampere. That is, if the potential difference between two ends of a conductor is 1 volt and the current in it is 1 ampere, then the resistance is 1 ohm. If the potential difference is 1 volt and it carries a current of 1 ampere, then we call it as the resistance, the conductor has a resistance of 1 ohm. I equals what? V by R. And also, see here, you can see here, V equals what? I R. Now R equals what? V by I. You can see here, R is inversely proportional to I. That means if the resistance increases, the current decreases. If the resistance increases, the current decreases. If the resistance decreases, the current increases. That means it is inversely proportional. You should know the relationship between the resistance and the current. You can see this point in the textbook. The current through a resistor is inversely proportional to its resistance. If the resistance is doubled, that means the current is get reduced to its half of the value. There are many practical cases where you need to increase or decrease the current. In that cases, we use a component called as rheostat, or we call that as variable resistance. Again, 1 mark important definition: define rheostat or define variable resistance. The name itself says that rheostat is a component where you can change the resistance of the circuit. In an electric circuit, a device called rheostat is used to change the resistance of the circuit. What is rheostat? Rheostat is a component which is used to what? Change the resistance in the circuit. Okay? Why we need to change the resistance in the circuit? To change the current. To change the current, the potential difference remains constant. To vary the current, to change the current, what you should do is, you should change the resistance. To change the resistance, what is the component we use? We use a component called as rheostat. To score good marks in science, you need lot of patience. Today's class you should attend completely, then only you will get all the questions. See, what is rheostat? Rheostat is a component or device which is used in an electric circuit to change the resistance in the circuit. Why we need to change this resistance? To change the value of current, or increase or decrease. So the resistance of a conductor. See, you have an experiment here. So you have a definition of resistor. Resistance is different from resistor. Resistor offers resistance. You can expect 1 mark or 2 mark difference between question. Write the difference between resistance and resistor. Resistance is the property of the conductor. Resistor is a device. A conductor having some appreciable resistance is called as resistor. Resistor offers resistance. So a component having higher resistance is called as poor conductor. A component having low resistance is called as good conductor. And insulator will have very high value of resistance. Now important question again: factors on which the resistance of a conductor depends on. The resistance of a conductor depends on 4 factors. That is, R is proportional to L, R is inversely proportional to A. That means if you remove the proportional, you will have a constant called as rho. R equals rho L by A. The resistance of a conductor depends on the length of the conductor, area of cross section, and also it depends on the nature of the material. So you can see here, the resistance of a conductor depends on its length L, area of cross section A, and nature of its material, and also it depends on the temperature of the conductor. So if it is asked for 2 marks, you should write all the 4 points. The resistance of a conductor depends on 4 factors: the length, the area of cross section, and the nature of its materials, and also it depends on the temperature. So you can see the formula R equals what? Rho L by A. What is rho here? Rho is a constant of proportionality called as electrical resistivity. The SI unit of resistivity is ohmmeter. Very important unit. What is the SI unit of resistance? Is ohm. Resistivity is ohmmeter. What is resistivity? It is defined as what? Constant of proportionality called as what? Resistivity. So resistivity is what? It is the property of a material to offer resistance, right? And also the SI unit of resistivity is ohm meter. The SI unit of resistance is ohm. SI unit of resistivity is ohm meter. And also we have one more important concept here is alloys generally have higher resistivity. Why? They can ask for give reason question. Because alloys do not oxidize or burn readily at high temperature. That's the reason where the alloys are most commonly used in heating devices like electric iron toasters, etc. So the resistivity of an alloy is what? It's higher than its constituent metals. That's why it is most applicably used in heating devices like electric iron toasters, etc. And also you have one more important give reason question here. Tungsten is widely used or exclusively used for filaments of electric bulb. Why? Because on heating it starts emitting light. That's why the tungsten is almost exclusively used for filaments of electric bulb. And also the copper and aluminum are generally used for electrical transmission lines. So in this paragraph you have learnt about the factors on which the resistance of a conductor depends on, and the important concept of resistivity, the SI unit of resistivity, and also higher the resistivity, that means the resistance value will be more. And also alloys have higher resistivity, because of that it is used commonly in heating devices like electric toasters, electric iron box, etc. And also tungsten is used almost exclusively for filaments of electric bulb. Why? Because on heating it starts emitting light. And generally copper and aluminum are used for electrical transmission lines. So you can see the resistivity of different conductors, insulators and alloys. Insulators generally they have higher resistivity when compared to alloys, and conductors will have the resistivity value is less. So in the examination you can expect question like they can give a table with different resistivity. You should tell the which the conductor or alloy or insulator have high conductivity. If the resistivity is more, that means the conductivity will be less. If the resistivity is less, conductivity will be more, which are inversely proportional. So solve all the questions, solve all the numericals from the examples. We can expect the numericals from the examples only based on the resistivity and based on Ohm's law. So you have a question here. Why are coils of electric toasters and electric iron made up of alloy rather than pure metal? Because they do not oxidize easily, and also they have higher resistivity. That's why they are used. Now resistance of a system of conductors. When the resistance are this is also important diagram. When the resistors are connected in series, the current will be same. The potential difference is divided across each resistance. The current remains same. The potential difference will be divided across each resistance, that is V equals V1 plus V2 plus V3. V1 plus V2 plus V3. The current will be same across all the resistors. In case of parallel, the potential difference will be same. whereas the current will be divided across each resistance as I1, I2 and I3. The effective resistance when connected in series, that is Rs equals R1 plus R2 plus R3. In case of parallel, it is 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. When the resistors are connected in series, the effective resistance is what? R1 plus R2 plus R3. When it is connected in parallel, the effective resistance 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. So this you should know to solve problems. In case of series, the current is same. The potential difference V is divided across each resistance. And also between these two, which is most used in domestic circuits, it is parallel connection. Parallel connection is widely used in domestic circuits. We'll see. You should list down all the advantages of parallel connection over series connection. In case of parallel connection, no need of in case of series connection, you should have the individual switches for each resistors to operate. You should have each switches across the resistance. If one gets spoiled, then other will stop working. In case of parallel, you have those two advantages. And also in case of series circuit, the resistance will be more. In case of parallel, the resistance will be less. You can go through this. And also the problems based on the example 12.7. So try to solve all the problems from the textbook itself. Many times you can expect the textbook questions only. So all these are very important problem. So based on the power, you can expect 2-mark question. Now there is an important concept of heating effect of electric current. So we know that cell generates a potential difference between 2 points. Name the component which creates potential difference. It is cell or the battery. Now, so a part of source energy in maintaining the current may be consumed into useful work, but rest of the energy is expended in the form of heat, right? Now that effect is called as what? The heating effect of electric current. So this heating effect is utilized in few devices like electric heater, electric iron box, electric toasters, etc. So the power input is defined as P equals V into I. The power input to a device is what? V into I. What is the power input? The power input is V into I. Then the heat dissipated, H equals VIT. If you apply Ohm's law, what we get is H equals I square RT. This is called as Joule's law of heating. The heat produced in a conductor is given by H equals VIT. Then applying Ohm's law, what we get is H equals I square RT. This is called as what? Joule's law. So state Joule's law of heating. H equals I square RT. The heat generated in a conductor is directly proportional to square of the current. Is directly proportional to square of the current, directly proportional to resistance for a given current, and directly proportional to the time for which the current flows through the resistance. So very important 2-mark law, or if you don't get law for 2 marks, definitely you can expect 2-mark numerical. So it will be from the textbook itself. The heat produced in a conductor is directly proportional to what? Square of the current, resistance of the conductor, and also time for which the current flows. This is called as what? Joule's law of heating. And next what we have is practical applications of heating effect of electric current. The heating effect is utilized in some of the devices such as laundry iron box, electric toaster, electric oven, electric kettle, electric heater, right? This all works on the principle of Joule's law. You can expect one MCQ based on this, that is electric oven, electric toaster works on the principle of dash, Ohm's law, Joule's law, some other law will be given. The correct answer is Joule's law of heating. So you have the reason here, right? Why tungsten is used in filaments of electric bulb? Because it has high melting point, it has high resistivity. On heating, it gives or it emits light. That's why the tungsten is widely used in the filaments of electric bulb. You can see the filament must retain as much of heat generated and it emits light. The very important property of tungsten is when it's get heated up, it emits light, and also it has the property of higher resistivity, and also it has high melting point. Because of high melting point, in case if it is asked for 2 marks, you should mention all these points, that is high melting point, high resistivity, and it emits light on heating. See, and also you have the bulbs are usually filled with chemically inactive nitrogen and argon gases to prolong the life of the filament. Name the gas which is used in the bulbs. What is the answer? It is nitrogen and argon gases. Why? If it is in case if it is application question, you can get question like why the bulbs are usually filled with nitrogen and argon gases? Because the answer is because nitrogen and argon gases, they have completely filled or the stable structure. They do not react with any other metal or non-metal, hence it is used in the filament. These gases, they do not react. Why? Because it is their valence shell is completely filled or octet structure. Now we have one more concept called as fuse. What is fuse? Fuse is an electrical safety devices which has low melting point. When the higher current flows to it, what happens? It melts and protects the circuit. See, it protects the circuit and appliances by stopping the flow of an unduly high electric current. Always the fuse is placed in series. How the fuse is placed in an electric circuit? It is placed in series. Students, it's taking time. Still, I am going in detail. You should try to make all these points. If you are watching this, definitely you can expect all these similar questions or same concept based question in the examination. Fuse. What is fuse here? It is an electrical safety device. Always it is placed in series, which has low melting point. Fuse will have low melting point. If the current flows more than the specified value, what happens? The fuse melts. The fuse will get heated up and it melts and it breaks the circuit. By thus, it protects the circuit and appliances. So you have a question here. A circuit of 4.54 ampere will flow in the circuit. That means we should choose a fuse of 5 ampere, right? Next we have concept of electric power. If you are lucky, you can expect 5 mark question based on electric power. What is electric power? It is the rate at which the electric energy is dissipated or consumed in an electric circuit. the rate at which the electrical energy is consumed in an electric circuit is called as what? Electric power. List the ways by which you can express the power. You have different formulas. That is, the first formula is P equals VI. P equals what? VI. Next, P equals I square R, or P equals V square by R. These are the ways by which you can express the power. What is the SI unit of power? The SI unit of power is watt. What is the SI unit of power? Watt. So define 1 watt. 1 watt is defined as what? If an appliance consumes what? 1 ampere of current when it is operated at a potential difference of what? 1 volt. Whether if it is 1 ohm, if the definition of 1 ampere or 1 volt or 1 watt or 1 ohm if it is asked, you should always relate this with the equations, then it will be very easy. P equals what? V into I. 1 watt equals what? 1 volt into 1 ampere. That means an electrical appliances is operated between a what? Potential difference of 1 volt if 1 ampere of current flows through it, right? 1000 watt is equal to what? 1 kilowatt. And also the unit of electrical energy is what? That is watt. What is the commercial unit of electrical energy? It is kilowatt hour. The commercial unit of electrical or the power is what? Kilowatt hour. Commonly it is called as unit. In case based on power, if they don't ask any question, you can expect 2 mark or 3 mark numerical. So you can solve what are the questions there in the textbook. That is more than enough. Now we'll do a small recap. We have started with defining what switch, an electric circuit, and the definition of electric charges, and the conventional flow of electrons, the definition of current, the SI unit of current, that is ampere, define 1 ampere, what is ammeter, how it is connected in an electric circuit, and the important diagram, simple electric circuit. And what we had is the concept of electric potential and potential difference. V equals what? W by Q. Define 1 volt. What is voltmeter? How it is connected in circuit? That is, always it is connected in parallel. And circuit symbols for 1 mark. Ohm's law. In case Ohm's law, if the table is given, you can calculate the value of resistance. That is, R equals V by I. For all the values, the resistance will be same. Or what you can do, you can plot the graph and you can find out the value. Roughly you can plot and you can find out. Then Ohm's law, the concept of resistance, definition of 1 ohm. Then the relationship between current and the resistance. If the current increases, the resistance decreases. Based on this, you can expect question. And you have the concept of rheostat. To change the current, what we use a component called as rheostat. Rheostat is usually used to what? Change the value of the resistance. Next, what we had is the value on which the factors on which the resistance of a conductor depends on, the concept of resistivity, SI unit of resistivity. And in the examination they'll give the table. Many times they have given the table having given different elements, material with the resistivity. If the resistivity is more, that means the conductivity will be less. If the resistivity is less, that means the conductor is more. Conductivity is more. And the problems and resistance of a system of resistors in series and resistors in parallel, which is more advantageous in domestic circuit. Parallel circuit is more advantageous than the series connection. Based on this, we can expect 2 mark problem. Then the concept of the heating effect of electric current. What is the power input? Power input is P equals V into I. Some appliances which works on the concept of heating effect of electric current. Then Joule's law of heating, 2 mark question. If it is not asked for law, if law is not asked, definitely can expect 2 mark problem. Practical applications of heating effect of electric current. You have the concept of filament. Why filament? The tungsten which is used in what? Filament of electric bulb, because the 3 properties you should know. It has higher resistivity, low melting point, and on heating it emits light. And also, which gas is used to fill the filament, sorry, to fill the bulbs? It is nitrogen and argon gases. One reason is to prolong the life of the filament. In case if the application question is asked, like nitrogen and argon gases are used to what? Prolong the life of the filament. Give reason or why. We can say that nitrogen and argon gases are completely filled because they do not react. Argon is it is placed in group 18. It is completely filled. And we have the concept of fuse. Fuse is then what? Electrical safety device which is placed in the series to protect what? The electric circuit and the appliances. In case of high duty current, it melts and breaks the circuit. And also concept of electric power. Different ways by which you can express the power is P equals V into I, P equals I square R, and P equals V square by R. What is 1 kilowatt? 1 kilowatt is what? 1000 watts. And also what is the commercial unit of power? It is kilowatt hour. Kilowatt hour. Commercially it is commonly known as unit. Okay, start. The unit, chemical reactions and equation. The important concept what you should learn from the examination point of view is definition of chemical equation as well as chemical reaction, and also the burning of the magnesium ribbon. Magnesium ribbon burns with a dazzling white flame and changes into white powder. Before burning magnesium ribbon, it should be cleaned. Why it should be cleaned? To remove the impurities. What kind of impurities? It is the outside layer reacts with the oxygen to form what? Magnesium oxide. What are the changes that takes place during the chemical reaction? Is it is change in state and change in color, evolution of gas, and also change in temperature. And also the word equation for the chemical equations, where you can write it in the form of what? The statement magnesium plus oxygen gives us what? Magnesium oxide. On the LHS we call it as reactants. On the RHS what we call it is product. Writing a chemical equation using symbols and also balancing a chemical equation is very important, because we know that by law of conservation of energy, mass can neither be created nor be destroyed in a chemical reaction. Because of that, the number of atoms present on the reactant side should be equal to number of atoms present on the product side. On the LHS and the RHS, the number of atoms should be same. Hence, the chemical equation must be balanced. Here we have an example how to balance a chemical equation. Here Fe plus H2. Fe plus H2 give us to what? Fe3O4 plus H2, right? This is a Fe plus H2O. Now we should balance this chemical equation. What is the first step? The first step is list down the element and number of atoms on LHS and RHS. The elements what we have is iron, hydrogen and oxygen. On LHS How many atoms are there? Iron has one, sorry, we have one atom of iron, then on the RHS we have 3. Then hydrogen we have 2 on the LHS and 2 on the RHS, and oxygen we have 1. Fe plus H2O 1, and on the RHS what we have is Fe plus H2O gives us Fe3O4 plus H2. Oxygen we have 1 atom in the LHS and 4 atoms in the RHS, right? Now you should start balancing the equation which has starting with the element which has highest number of atoms. Here we have oxygen 4 atoms, maximum 4 atoms. You should balance with what? Oxygen. Now on the LHS we have 1, we should make it 4, multiply by 4. It becomes what? 4H2O. Now hydrogen has become what? 8. On the RHS I should make it 8, multiply by 4. Now on the RHS we have 3 iron atoms. On the LHS I should make it 3, multiply by 3. So balanced chemical equation is 3Fe plus 4H2O give us what? Fe3O4 plus 4H2, right? This is how you will balance a chemical equation. First list down the element, list down the number of elements on the LHS, list down the number of atoms on the RHS. Start balancing with the element which has highest number of atoms. And there are few chemical equations are there. Try to balance those, and we have chemical equation that is for photosynthesis, and also we have the types of, we have 3 questions in the exercise. In the in-text questions we have 3 questions, question number 1, 2 and 3. All these 3 questions are very important from the examination point of view, because many a time these questions have been, same questions have been repeated in the examination. And also there are 4 types of chemical reactions. One is combination, next is decomposition, next displacement and double displacement. So all these 4 types of chemical reactions are very important. What is a combination reaction? A single product is formed by the reaction of 2 or more reactants. It is called as what? Combination reaction. So what is an example for combination reaction is CaO plus H2O gives to CaOH twice plus heat. That is quicklime in water gives what? The slaked lime plus liberation of heat. When the heat is liberated in an chemical reaction, we call that as exothermic reaction. But all combination reactions are exothermic reactions, because in combination reaction the heat is evolved. What is exothermic reaction? Heat is released or generated with the formation of product. It's called as what? Exothermic chemical reaction. There are few examples are there for. All combination reactions are exothermic reaction, because with the formation of product the heat is evolved or released. Here burning of natural gas is an example. CH4 plus 2O2 gives to CO2 plus 2H2O. It is an exothermic reaction. Why? Because the heat is evolved in the reaction. And also respiration is an exothermic process. Why? Give reason. Because during digestion food is broken down into simpler substances. For example, rice, potatoes, bread contain carbohydrates, right? These carbohydrates are broken down into simple sugar molecules called as what? Glucose. This glucose combined with oxygen in the cells of our body and provides energy. That is, the heat is evolved, the heat is generated, the energy is liberated. Hence respiration is an exothermic reaction. C6H12O6 glucose plus with combining with oxygen gave us what? 6CO2 plus 6H2O plus energy. And also the decomposition of vegetable matter is also example for exothermic reaction. Give reason. You should know the reason. The next type of reaction is decomposition reaction. What is decomposition reaction? A single reactant decomposes into two or more products. It's called as what? Decomposition reaction. What is decomposition reaction? Decomposition reaction is a type of chemical reaction in which a reactant will decompose or splits into two or more products, right? Here we have an example. 2FeSO4, that is ferrous sulfate, on heating gives ferric oxide with release of SO2 plus SO3. Very important reaction, very important. You can mark it as important reaction. 2Fe plus SO4 gives what? Fe3O3 plus SO2 plus SO4. SO2 plus SO3. Here you can see a single reactant breaks down to two or more products. This is an example for decomposition reaction. Ferrous sulfate crystals lose water when heated. The color of crystal changes. Then it decomposes into ferric oxide, sulfur dioxide, sulfur trioxide. Ferric oxide is a solid, whereas sulfur dioxide and sulfur trioxide are gases. And also we have one more example, decomposition of calcium carbonate to give calcium oxide and carbon dioxide. So this reaction, that is CaCO3, gives us to CaO plus CO2. It is a very important industrial application because calcium oxide is called lime or quicklime. It has many uses. It is used in the manufacture of cement. Name the compound which is used in the manufacture of cement. It is calcium oxide. What it is? Calcium oxide. What is another name of calcium oxide? It is quicklime. Quicklime. See, we have one more important reaction that is based on the decomposition reaction. Reaction of lead nitrate. The heating of lead nitrate gives what? Lead oxide plus release of brown fumes. What is the brown fumes? It is nitrogen dioxide. So on heating of lead nitrate releases a brown fumes. What is the gas called? It is what? Nitrogen dioxide. Very important reaction again. Based on decomposition reaction, definitely you can expect question. And very important diagram, electrolysis of water. Again I am repeating this question. Name the brown fumes produced on heating lead nitrate. What is the gas called? Nitrogen dioxide. Important diagram, 3-mark diagram, electrolysis of water. We have few more decomposition reaction. When silver chloride on exposed to sunlight, it decomposes into silver chloride and silver and chlorine. When silver chloride on exposing to sunlight, it decomposes into silver and chlorine. So this reaction is used in what? And we have one more reaction. Silver bromide on exposed to what? Sunlight, it gives silver and bromine. See, these kind of reactions, they require energy either in the form of heat, light or electricity for breaking down the reactant. Hence it is called as what? Endothermic reaction. Endothermic reaction in which the heat energy or the light energy or electrical energy is utilized to break the reactants. Hence it is called as what? Endothermic reaction. Endothermic reaction. You can expect the difference between the exothermic and endothermic reactions. And also name the reaction which is used in black and white photography. What is that reaction? 2AgCl gives to 2Ag plus Cl2. A solution of substance X is used in whitewashing. Name the substance. What is the substance which is used in whitewashing? Huh? Name a substance which is used for whitewashing. It is calcium oxide. CaO. Its formula is CaO. Write the reaction of substance X with water. That is CaO plus H2O gives CaOH twice. See, why is the amount of gas collected in one of the test tube is double the amount? Because it is an hydrogen gas. Oxygen and hydrogen gas will be in the ratio 1:2. Again, displacement reaction. What is displacement reaction? A high reactive element displaces the less reactive element. Here, the iron is more reactive than copper. That means copper is displaced by iron. That is FeSO4 plus Cu. In the same way, you have zinc plus copper sulfate solution. Copper is displaced by zinc because copper is more reactive than zinc is more reactive than copper. Lead plus CuCl2, copper chloride, on gives what? Lead chloride, because lead is more reactive than copper. So in the examination you can expect 4 chemical reactions will be given, where you should identify the incorrect chemical reactions or the equations. Okay, next what we have is very important, double displacement reaction. What is double displacement reaction? A chemical reaction in which exchange of ions takes place in the solution. Exchange of ions takes place between the reactants is called as what? Double displacement reaction. Here the reactions in which there is an exchange of ions between the reactants are called as what? Double displacement reaction. Example for double displacement reaction is sodium sulfate plus barium chloride gives what? Barium sulfate plus sodium chloride. Here barium sulfate is a precipitate. What is the white precipitate in this reaction? Barium sulfate, right? It is also called as what? Precipitation reaction. Any reaction which produces a precipitate is called as what? Precipitate reaction. It is called as what? Precipitate reaction. Here what is the precipitate formed? It is barium sulfate. What is the precipitate formed? What is the precipitate formed? This white precipitate is formed by reaction of which ions? You can see here SO4 2 minus and Ba 2 plus. The reaction of SO4 2 minus and Ba 2 plus gives what? The white precipitate, sulfate ion and barium ion. The reaction of sulfate ions and barium ion gives what? The white precipitate, barium sulfate. So you should learn this chemical equation. And next we have is oxidation and reduction. What is oxidation? A chemical reaction in which if a substance gains oxygen is called as what? Oxidation. And those substance is called as oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. That means if the oxygen is removed, then it is called as what? Reduction. If a substance gains oxygen, we call it as oxidation. What is oxidation? A reaction in which a substance gains oxygen. What is reduction? A reaction in which oxygen is lost. If a substance loses oxygen during a reaction, it is called as reduction. If it gains oxygen, it is called as oxidation. In this reaction, 2Cu plus O2 copper is getting oxidized. Copper gains oxygen. That means copper is oxidized. Whereas in this equation, copper oxide, it is losing oxygen. That means CuO is reduced. What CuO? That means CuO is reduced. See, if oxidation and reduction takes place simultaneously in a chemical reaction, during a chemical reaction, it is called as what? Redox reaction. The chemical reactions in which oxidation reduction takes place, it is called as what? Redox reaction, right? Here CuO plus H2 gives what? Cu plus H2. Which substance is reduced? CuO is reduced to Cu, whereas H2 gains oxygen. That means H2 is oxidized. Okay, we have few more examples. ZNO plus gives Zn plus CO. Which substance is reduced here? ZNO is reduced to Zn. The answer is ZNO. Whereas which substance gains oxygen? C. That is, carbon is gaining oxygen. That means the answer is C. Which substance is reduced? ZNO. Which substance is oxidized? C. 4MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Which substance is reduced? MnO2. Which substance is gaining oxygen? H hydrogen. Next, we have very important concept, corrosion and rancidity. So when iron particle exposed to what? The atmosphere, it gets a reddish brown powder left for some time. This process is called as what? Rusting of iron. Generally for all the metals we call that as what? Corrosion. In case of copper and silver, we have a, in case of copper we have a green coating called as corrosion. In case of silver it is black. When metal is attacked by substances around it such as moisture, acids, etc., it is said to corrode. This process is called as what? Corrosion. Very important definition. Corrosion. What is corrosion? When the metal is attacked by substances such as moisture, acids, etc., it will the metal will get corroded. This process is called as corrosion. Whereas we can see the black coating on silver articles and green coating on the copper are examples of corrosion. Whereas in case of iron, the rust is formed. How can you avoid rusting? You can avoid rusting by, you can paint the iron articles to avoid corrosion, and also you can use lubricants, and coating a layer of zinc is called as galvanization, right? So these are the ways by which you can avoid corrosion. See, what is rancidity? When oil containing food or food containing oil, if it is exposed to air or kept for a long time, what happens? It gets oxidized, gives to what? The food gets spoiled and gives bad smell. This process is called as what? Rancidity. How can you prevent rancidity? You can prevent rancidity by using antioxidants, or in case of chips manufacturer, usually they flush chips with gas such as nitrogen to prevent the rancidity. What is rancidity? It is nothing but oxidation reaction. How rancidity can be prevented? By using antioxidants. What are antioxidants? Antioxidants are the substance which prevent oxidation. Is called as what? Antioxidants. So food containing oil are usually flushed with some kind of gases to prevent what? Rancidity. In case of chip manufacturer, they flush the nitrogen gas. Why? To prevent the rancidity of the chips. That's why usually it is not preferred to eat the chips outside. So dear students, from this unit you can expect around 5 to 6 marks based on the chemical reaction balancing. Definite questions will be there based on the double displacement reaction, based on the decomposition reaction. Those reactions are very important. The difference between exothermic, endothermic, and why combination reaction is an exothermic reaction. All these concepts are very important. So if you study concept, see, if you revise the chapter by reading textbook, you can finish each chapter by 30 minutes. If you start reading any workbook or worksheet, then it will be very difficult to complete the portions. Especially if you want to score good marks in science, you should read textbook. And also by making a note of each point, in a notebook is very important, because you should remember those key words to write in the examination. Now the unit acid, bases and salt, again it is a very important unit from the examination point of view. Here the important thing what you are going to learn is the taste of acids. Acids are sour in taste and they change the color of blue litmus to red. Acids, difference between acid and bases: acids are sour in taste, which change the blue litmus to red. Opposite to that is red litmus to blue, that is changed by the bases, which are bitter in taste. Acids are sour in taste and they change the what? Blue litmus to red, whereas the bases are taste. Which taste? Bases are bitter in taste and they change the color of red litmus to blue litmus. What is litmus? Litmus is a indicator. It is a natural indicator which indicates the presence of acid or bases by changing the color. Turmeric is another indicator. Next, you should learn the examples for olfactory indicators. What are olfactory indicators? The substance which changes the odor, that means smell. The substance which changes its smell in the presence of acid or base is called as olfactory indicators. Example for olfactory indicators is very important. Examples for olfactory indicators are vanilla essence, onion and clove are the examples for olfactory indicators. What are olfactory indicators? Olfactory indicators are the substance which changes its odor in the presence of acid or base is called as what? Olfactory indicators. Now we'll see the reaction of acid and bases with the metals. This diagram, that is reaction of zinc granules with dilute sulfuric acid and testing hydrogen gas, very important 3-mark diagram. Very important. The 3-mark diagram will be asked from acid, bases or salt, or from metals and non-metals. Reaction of zinc granules with dilute sulfuric acid and testing of hydrogen gas. Very important question diagram. Next, when acid reacts with metal, which gas is released? The release hydrogen. They release what? Hydrogen gas. When metal react with acid, hydrogen gas is evolved or it is released with what? With forming compound salt. We have an example here, 2NaOH. The reaction of zinc with sodium hydroxide gives what? Sodium zincate. Please write down the reaction in a notebook. Reaction of zinc with what? Sodium hydroxide gives what? Sodium zincate. Sodium zincate. One more question can be asked like this: the reaction of zinc with the base sodium hydroxide gives what? Or the name the product formed when the zinc reacts with sodium hydroxide. What is the answer? Sodium zincate. Na2ZnO2. Na2ZnO2 with release of hydrogen gas. How do Metal carbonates and metal hydrogen carbonates react with acid. Metal carbonates, metal hydrogen carbonate reacting with acid releases what? Carbon dioxide gas. Name the gas release when sodium carbonate and sodium hydrogen carbonate is reacts with acid. What is the gas released? Carbon dioxide gas. These reactions are very important from the examination point of view. Very important reactions from the examination point of view. On passing carbon dioxide gas through this lime water, what we get is we get a white precipitate called as what? Calcium carbonate. Again, on passing excess carbon dioxide, what we get is calcium hydrogen carbonate. What we get is calcium hydrogen carbonate, which is soluble in water. It is not a precipitate, it is a soluble substance. Let me revise this concept. The reaction of metal carbonates and metal hydrogen carbonates with acid gives the release of what? The carbon dioxide gas with formation of salt and water. On passing this carbon dioxide, the released carbon dioxide gas through what? Lime water. It forms a white precipitate called as what? Calcium carbonate. On passing excess carbon dioxide gas through this calcium carbonate, it forms a soluble substance called as what? Calcium hydrogen carbonate. What it is?
Calcium hydrogen carbonate.
We can see a metal carbonate or metal hydrogen carbonate with acid gives what? Salt, carbon dioxide and water. Metal reacts with acid gives which gas? Hydrogen gas. Metal carbonate or metal hydrogen carbonate with acid gives carbon dioxide gas. You should know the difference between these two. Metal react with acid to form what? Which gas? Metal react with acid to form which gas? Metal carbonate or metal hydrogen carbonate with acid gives which gas?
Carbon dioxide.
Now the next important concept is how acid and bases react with each other. Acid and base react with each other to form what? Salt and water. This is called as what? Neutralization reaction. The reaction between acid and the base to give salt and water is called as what? Neutralization reaction. Base plus acid gives what? Salt plus water. Example, NaOH, which is a base, react with acid. HCl gives NaCl, which is a salt, and it gives what? Water. It is an example for neutralization reaction, a chemical reaction in which acid and base reacts to form what? Salt and water is called neutralization reaction. Now, reaction of metallic oxide with acid. Metallic oxide reacts with acid to give salt and water. To give salt and water, acid should react with what? Base. That means here metal oxide reacts as a what? Base, which is basic in nature. Metal oxides are basic in nature, which reacts with acid to give what? Salt and water. Now, in the same way, the reaction of non-metallic oxide with base. The reaction of non-metallic oxide with base gives what? Salt and water. That means the non-metallic oxides are acidic in nature. Acidic in nature. Metal oxides are basic in nature. Non-metallic oxides are acid in nature. So example for non-metallic oxide is? Yes, example for non-metallic oxide is calcium hydroxide, which can be asked in MCQ. Here the example for non-metallic oxide is carbon dioxide and metallic oxide is?
Calcium hydroxide.
Yes. Make a note of this. Example for non-metallic is calcium dioxide. Example for metallic oxide is cal calcium hydroxide. Example for non-metallic oxide is calcium dioxide. So it's confusing here. I'll write here. You can write down non-metallic oxide. It is calcium. Example for non-metallic oxide is carbon dioxide. Metallic oxide is
calcium hydroxide.
calcium.
Hydroxide.
So let me conclude. Example for non-metallic oxide is carbon dioxide. Metallic oxide is calcium hydroxide. So non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. So all these questions are very important to try to revise in text question. And also acid solution in water conducts electricity, important 3 or 2 mark. 2, it can be asked for 2 or 3 mark. Next, what do all acids and bases have in common? All the acids will have H plus ion. Acid contains H plus ions. Acid contains H plus ions, hydrogen ions. Acid in water produces H plus ions. Acid in water produces what? H plus ions. Whereas base has hydroxyl ion, hydroxide ion. Acid has H. Acid has H plus ions. Base has OH minus ions. Acid has what? H plus ions. Bases has OH minus ions in water. So these H plus ions are responsible for their acidic properties. See, acid in water gives a H plus ions. Again, this H plus ion combines with water molecule to form what? Hydronium ion. H3O plus. H3O plus. Why hydronium ion is formed? Because hydrogen ions cannot exist alone. Hence, it combines with water molecules to form hydronium ion. 1 mark definition. Define hydronium ion. H3O plus ion is called as hydronium ion. Simple definition, otherwise you can write hydrogen cannot exist alone. It reacts with water molecule. Hence it forms hydronium ion. What is hydronium ion? H3O plus. Again, NaOH in water gives Na plus OH minus. That means all bases have what? Hydroxide ions in common. The bases which are soluble in water, are called as what? Alkalis. This question has been asked in preparatory. What are alkalis? Alkalis are the substances or the bases which are soluble in water are called as what? Alkalis. Definition of hydronium ion and alkalis are important. Again, we have the concept in the process of dissolving acid or base in water is highly exothermic one. That means more amount of heat is evolved. That means we must have some precautions when you are dissolving an acid or base in the water. That means the acid must always be added slowly to water with constant stirring. Acid must be always added to the water, not water to acid. Because if you add water to acid, because it is an highly exothermic reaction, the acid might be splashed out and it can cause injury. If water is added to the concentrated acid, the heat generated may cause the mixture to splash out and cause burns. Hence, it is always advised to put acid to the water slowly with constant stirring. So mixing, again, it is a very important concept. Mixing acid or base with water results in the decrease of ions. Mixing, that means that process is called as what? Dilution. Dilution means adding water to the acid or bases, which results in the decrease of H plus or OH minus ions in acid or base. Such process is called as what? Dilution. See, out of 6 questions in the in-text question, definite one question will be asked. So, very simple question. Make a note of all those questions, study those questions. Why does aqueous solution of acid conduct the electricity? Because acid in water gives its respective ions, that is H plus and H plus ion, cation and anion, right, which is responsible for the conduction of electricity. Why does dry HCl gas does not change the color of dry litmus paper? Because it does not produce any ions. While diluting an acid, it is recommended that acid should be added to water, because if water is added to acid, what happens? The mixture is the heat produced results in the splashing out of the mixture. How is the concentration of hydronium ion affected when a solution of acid is diluted? It decreases, right? How strong are acid or bases? It is measured by a scale called as what? pH scale. A scale for measuring hydrogen ion concentration in a solution is called as what? pH scale. pH scale ranges from 0 to 14. 0 to 7 is acidic in nature. 7 to 14 is basic in nature. 7 is what? Neutral solution. A solution has a pH of 5. That means the solution is acidic or basic in nature. Acidic in nature. A solution has a pH of 14. What is the nature of the solution? Basic. A solution has pH of 7. What is the nature of the solution? Neutral solution, right? So with the increase in value of pH scale, the basic property increases. With decrease in what? The pH value, that means the acidic property increases. Exactly 7 gives what? The neutral solution. 7 to 14, OH minus ion increases. 0 to 7, H plus ion. The strength of acid or base depends on the number of H plus or OH minus ions produced. Acid that produces more H plus ions are called strong acid. Less H plus ion, weak acids. Now the next concept is importance of pH in everyday life. Based on this concept, 1 mark question will be asked or 2 marks. What is acid rain? When the pH of the rainwater is less than 5.6, is called as what? Acid rain. Next, what is the pH of the soil in your backyard? Plant requires specific pH range for their healthy growth. In case of decrease in the pH, in case of decrease in the pH value of the soil, you can use a suitable base to neutralize it. pH in our digestive system, our stomach produces the highly concentrated acid called as what? Hydrochloric acid. This acid helps in the digestion of food without harming the stomach. How? The stomach produces one more substance called as what? Mucus, which protects the inner lining of the stomach. Whereas during indigestion, the stomach produces too much acid. This causes what? Pain and irritation. This is called as what? This condition is called as acidity. To treat the acidity, we use some kind of bases called as what? Antacids. Antacids are basic in nature. In case of excess acid, in case of acidity, what is the um, uh, prescribed medicine? Antacids. Antacids neutralize the excess acid produced in the stomach. Example for antacids are magnesium hydroxide, which is milk of magnesia. pH change as the cause of tooth decay. Next, tooth enamel is made up of calcium hydroxyapatite. What is tooth enamel is made up of? So bacteria present in the mouth produces acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent the tooth decay is what? By using toothpaste. Toothpaste are generally basic in nature. Why? Because the acids produced by the acid produced by the degradation of the sugar by the bacteria. It should be neutralized, right, to prevent the tooth decay. Hence we use what? Suitable toothpaste to prevent what? Tooth decay. Self-defense by animals and plants through what? Chemical warfare. Honeybee or bee sting, if it bites, it causes what? Pain and irritation. What it contains? It contains an acid called as what? Methanoic acid. The sting of bee contains which acid? Methanoic acid. What is another name of methanoic acid? How we can prevent, how can you reduce the pain and irritation? By using what? Mild acid like baking soda, which gives what? Relief. So all this you can check it out. The acid present in some of the natural resources. What is acid present in curd? It is lactic acid, lemon, citric acid, tomato, oxalic acid, tamarind, tartaric acid, orange, citric acid, vinegar, acetic acid, nettle sting, methanoic acid or formic acid. Now more about salt. Family of salts, definite 2-mark question. The reaction of shear when electricity is passed through aqueous solution of sodium chloride is called what? Brine. What is brine? When electricity is passed through aqueous solution of sodium chloride, brine, it decomposes to form sodium hydroxide. This process is called as what? Chloralkali process. Chloralkali process. The products formed here as chlorine, hydrogen and NOH, right? This has many uses, right? Chlorine gas is produced at the anode. Chlorine gas is produced at the anode. Hydrogen gas is produced at the cathode. And sodium hydroxide solution is formed near the cathode. Okay, you can see here, right, in the figure. Now we should know the uses of all this. Define chloralkali process. Write the products formed. Write the uses of each product formed. What is chloralkali process? When the electricity is passed through an aqueous solution of sodium chloride, it is called what? Brine. It decomposes to form sodium hydroxide. The process is called as what? Chloralkali process. 2NaCl. Reaction is very important. 2NaCl plus 2H2 gives us what? 2NaOH plus Cl2 plus H2. Name the products formed. Name the products formed in chloralkali process. It is sodium hydroxide, chlorine and hydrogen. See, what is the uses of chlorine gas? Water treatment, swimming pools, PVC, disinfectants, CFCs and pesticides. Uses of hydrogen gas, fuels, margarine, ammonia for fertilizers. Uses of sodium hydroxide, degreasing metals, soaps and detergent, paper making and artificial satellite. Important 3-mark question. Define chloralkali process, write the products formed in chloralkali process and write the uses of each product formed in the chloralkali process. And also the chlorine gas is produced as which anode? Hydrogen gas is produced at which electrode? It is cathode. Now the salts, we have salts, right? Bleaching powder, baking soda, washing soda. Here with the users, you should know the preparation also. You should know how bleaching powder is prepared. You should know how baking soda is prepared. You should know how the washing soda is prepared. Preparation is very important. Not only with the users, you should know the preparation of those salts with chemical equations. And also the POP. The POP and also the concept of water of crystallization is also very important. Now we'll see each of bleaching powder. How bleaching powder is produced? Bleaching powder is produced by the action of chlorine on the dry slacked lime, that is calcium hydroxide. Bleaching the chemical name for bleaching powder is CaOCl2. Uses, we can read it for 2 marks. Baking soda. How baking soda is prepared? The baking soda is commonly used in the kitchen for making tasty crispy, right? What is the compound, what is the name of the baking soda? Sodium hydrogen carbon. It is produced by using sodium chloride as one of the raw materials. NaCl plus H2O plus CO2 plus NaC gives NH4 plus Cl plus Na with CO3, sodium hydrogen carbon, which is a baking soda. Baking soda, baking powder is prepared by using baking soda. See, sodium hydrogen carbonate is also used as an ingredient in antacids. That means it is basic in nature. And also baking soda is used in what? Soda acid fire extinguishers. For making baking powder, mixture of baking soda, sodium hydrogen carbon and mild edible acids such as tartaric acid. If it is mixed, what happens? You get baking powder. So which gas is produced during the reaction which causes the bread or cake to rise? Carbon dioxide gas is produced, which makes them soft and spongy. Uses of washing soda is very important. And also water of crystallization. Water of crystallization is the fixed number of water molecule present in one formula unit of salt. So preparation of washing soda is also very important. How washing soda is prepared? Washing soda is prepared by the heating baking soda, and recrystallization of sodium carbon gives what? Washing soda. Na2CO3 plus 10H2 gives Na2CO3 dot 10H2O. That means Na2 contains 10 molecules of water. Plaster of Paris. On heating gypsum of 373 Kelvin, it loses water molecules and become calcium sulfate hemihydrate. This is called as what? Plaster of Paris. The substance which doctors used plaster for supporting fractured bones is what? POP. POP is a white powder. On mixing with water, it changes to gypsum. CaSO4 dot half H2O plus 1.5 H2O gives what? CaSO4 dot 2 H2O. Uses of POP is also very important. POP is used in making what? Toys, materials for decoration and making surfaces smooth, and also it is used by the doctors in supporting the fractured bone. So very simple and easy chapter to score 7 marks or 6 to 7 marks. With the uses of salts, you should know the preparation of those salts with the chemical reaction, and also the common name of those salts or the chemical name is also very important. And also chloralkali process, neutralization reaction, all those are very important. The acid present in bee sting is methanoic acid or formic acid. Example for antacids are milk of magnesia. It is used in what? Acidity. pH scale. All those are very important concepts. Definition of hydronium ion. So you should read the textbook to score good marks. Unit life process, you can expect 7 to 8 marks from this unit, and also 4 or 5 marks questions from this unit. So very important chapter, you can expect 4 marks diagram also and 3 mark question. So in this chapter what you need to concentrate is definition of life process, the processes involved to maintain the life of an individual, and the 4 in-text questions. Why diffusion insufficient to meet the oxygen requirement of multicellular organisms like humans? What criteria do we use to decide whether something is alive or not? What are outside raw materials used by an organism? What process you consider essential for maintaining the life, like nutrition, digestion, respiration, transportation, excretion. So coming to the nutrition, here the important thing, the difference between autotrophic and heterotrophic nutrition is very important, and also the chemical equation representing photosynthesis, the chemical equation for photosynthesis. And for 3 mark question, events that takes place during the photosynthesis, that is absorption of light energy by chlorophyll, conversion of light energy to chemical energy, and splitting water molecule into hydrogen and oxygen, reduction of carbon dioxide to carbohydrates. These are the 3 events that takes place during photosynthesis. Again 3 mark question. Desert plant take carbon dioxide gas at night. Give reason. Important question. And important diagram, open and close stomatal pore, and also the function of God cells. The function of God cells, the function of stomatal pore during photosynthesis is an important question. Function of God cells, when God cells swell, that is water flows into them causing stomatal pore to open. Similarly, the pore closes if the God cell shrink. And important concept, heterotrophic nutrition. Difference between autotrophic and heterotrophic nutrition, very important, 2 or 3 mark question. And the nutrition in amoeba. So you can write the stepwise if it is asked for 3 marks with diagram, with a simple diagram. And coming to nutrition in human beings, nutrition in human beings, you should list down all the parts of the human alimentary canal with their function. So in one of the exam they have asked. So starting from the mouth, you should list down all the functions of the alimentary canal. So what is alimentary canal? It is a basically long tube extending from mouth to the anus. Here the function of the saliva, The saliva contains an enzyme called as what? Salivary amylase that breaks down the starch into simple sugar. In one of the exam, the question has been asked, the chapati tastes sweeter when it is chewed. Give reason. Because chapati contains starch, when salivary amylase acts on it converted into simple sugar. And the function of the muscular tongue. Next, the meaning of peristaltic movements from the mouth. The function of stomach, it releases three important gastric juices. What are those? Hydrochloric acid, pepsin, and mucus. The function of hydrochloric acid, the function of protein digesting enzyme pepsin, and mucus. You should know the function of each gastric juice. The function of hydrochloric acid is it creates acidic medium which facilitates the action of enzyme pepsin, and also it kills any microorganism which enters the stomach. The function of mucus is it protects the inner lining of the stomach from the action of the acid. The function of sphincter muscle, and the longest part of the alimentary canal is what? Small intestine. The longest part of the alimentary canal is small intestine. So the length of the small intestine differs in various animals depending on the food they eat. Herbivores eating grass need a longer small intestine to digest the cellulose, whereas meat is easier to digest. Hence carnivores like tigers have shorter small intestine. What they have? And also based on small intestine there are three questions are there. One is the longest part is what? Longest part of the alimentary canal is small intestine, and also the part of complete digestion is small intestine. The small intestine is a complete site of complete digestion of carbohydrate, proteins, and fats. So the function of bile juice, how fats are digested, very important question. How fats are digested in our body. Function of trypsin, trypsin for digesting proteins, lipase for breaking down the emulsified fat. The emulsification of fat is very important. The walls of small intestine contain glands which secretes intestinal juice. The enzyme present in it convert the proteins to what? Proteins to amino acid, complex carbohydrates to glucose, and fats to fatty acids and glycerol. How the function of villi. The function of villi, again 2 mark important question. So from the concept or the part unit, definitely you can expect the question. The function of digested food is taken up by the walls of the intestine. The inner lining of the small intestine has numerous finger-like projections called villi, which increase the surface area of absorption. The villi are richly supplied with what? Blood vessels, and take the absorbed food to each and every cell of the body, where it is utilized for obtaining energy, building up new tissues, and repair the whole tissue. The waste, the unabsorbed food is sent to the large intestine, where its wall absorb more water from its material, and rest of the material is removed from the body as waste via anus. The exit of which this waste is material is regulated by anal sphincter. Difference between autotrophic and heterotrophic nutrition. role of acid in our stomach, function of digestive enzymes. You should list down each and every digestive enzyme starting from salivary amylase. Again, 3 mark important question. Breakdown of glucose by various pathways. So the 6 carbon molecule is in cytoplasm converted into 3 carbon molecule. Again, in absence of oxygen, it is converted to ethanol, carbon dioxide and energy. Lack of oxygen, that is in our muscle cells, it is converted into lactic acid and energy. The presence of oxygen, carbon dioxide, water and energy. Uh, Means during sudden activity, cramps are caused due to the buildup of lactic acid in our stomach, so in our muscles. What is the 6 carbon molecule? It is a glucose. What is the 3 carbon molecule? It is pyruvate. The energy released during the cellular respiration is immediately used to synthesize a molecule called as ATP. ATP, which is used to fuel all the activities in the cell. In this processes, ATP is broken down, giving rise to fixed amount of energy. So the energy currency in our body is ATP. So this ATP molecule give energy for the endothermic reaction that takes place in the cell. Difference between aerobic and anaerobic respiration, again important 3 mark question. Plants exchange gases through stomata. So give reason. At night, when there is no photosynthesis occurring, CO2 elimination is a major exchange. Give reason. Why? Important question. At night, there is no photosynthesis takes place because of absence of sunlight. But instead, oxygen is released at this time. So terrestrial animals can breathe the oxygen in the atmosphere, but the aquatic animals that live in water need to use the oxygen that is dissolved in the water. Again, give reason question. Since the amount of dissolved oxygen is fairly low compared to the amount of oxygen in the air, the rate of breathing in aquatic animals is much faster than that seen in the terrestrial organisms. Very important question. So the breathing rate is faster in case of aquatic animals because the amount of dissolved oxygen is fairly low compared to the amount of oxygen present in the air. Now we'll see the next life processes, that is respiration. In human beings, air is taken into the body through what? Nostrils. That is the function of the nostril. You should know the function of nostril and the function of fine hairs present inside the nostril, and also rings, the functions of rings of cartilage. It ensures that air passage does not collapse. Function of rings of cartilage, and also the function of alveoli, and how oxygen and carbon dioxide is transported in the human beings. Very important question. How oxygen and carbon dioxide transported in human beings? Oxygen is carried by the respiratory pigment hemoglobin, whereas the carbon dioxide which is soluble in water, is mostly transported in dissolved form in our blood itself. So how the transport of oxygen and carbon dioxide in human beings is very important question. So oxygen is transported by the respiratory pigment which has high affinity towards oxygen, whereas carbon dioxide is transported in the dissolved form. That is, carbon dioxide is soluble in water and it is transported in dissolved form. Transportation in human beings. So important diagram, heart and also function of each part of the heart and uh, double circulation. The concept of double circulation is also very important. The three chambered heart is more advantageous than two chambered heart. How, why oxygenated and deoxygenated blood is separated, you should know all these concepts, and definitely you should learn about the concept of double circulation. And you should know the difference between arteries, veins and capillaries. You should know the difference between what? Arteries, veins and capillaries. Arteries have thick and elastic wall, whereas veins have what? Yes, they don't need thick walls. The function of platelets along with the function of lymph. So many times the function of lymph has repeated in the exam, and also the platelet, function of platelet, like blood clotting. So transportation in plants, transport of water and transport of soluble minerals, transport of food, transport of exchange of gases, very important, definite 3-mark question. And also you should know the concept of transpiration and translocation. Difference between transpiration and translocation. Transpiration is the loss of water from the plant body, whereas translocation is the transportation of food. Transportation of food you should know. And also, so how the food is transported, using what? ATP molecule. ATP you already know that ATP is used to what? To carry out endothermic reaction, or it is energy is released. And excretion. See all this from the unit life process. All the in-text questions are very important. Try to read all the in-text questions. And excretion in human beings, function of each part, and also definition of excretion, and how carbon dioxide is removed from the blood, and function and structure of nephron is very important. For many years, brain and heart have been repeatedly asked in the exam. This year, chances are there that you can expect structure of nephron. And the urinary bladder is muscular, and we have the control to urinate, because the bladder is muscular and it is nervous control. And very important question I have missed out. And list down all the excretory products in plants. Important question for your examination. Dear students, try to read out all the in-text questions first from the unit life process. Try to practice all the diagrams. Maximum you can expect 7 to 8 marks from this unit. So in biology, the important thing is you should attempt all the questions.